Well, welcome to this more practice factoring polynomial video. I'm just going to put some random problems on here, and based on what we've seen so far, let's see if we can classify what we have to do to these problems to factor them. Right here we have a quadratic trinomial. A is 1. This should be an easy factor. I'm going to go ahead and put A is 1, B is 3, and C is 2. I'm going to create a factor sum chart. I need factors of 2 that sum to 3. So the only factors of 2 are 1 and 2. Both these factors have to be positive because I need a positive sum. When I add these, I do get 3. So we don't have to do factor by grouping because A is equal to 1. So we can go straight to the multiplication problem where X is up front in both. And I use both these factors, X plus 1 and X plus 2. Again, you can have these in different orders, these parentheses. Okay, it doesn't matter. And of course, you could always check your work by foiling. Maybe pause the video and see how you can handle this one, and then you can come back if you need to, or you can fast forward to the next problem. Quadratic trinomial should be an easy factor. I want a factor sum chart. A times C is 8. Oh goodness, I keep forgetting to put a B there. And I want to sum to -9. Factors of 8, 1 and 8, 2 and 4, and that's it. Because I want the sum of each set of factors to be a negative, I want to make each factor negative. So -1 plus -8 is -9. So this is going to be the set of factors that I'm going to use to create my multiplication problem. Even if I went forward and added these two negative numbers, that's -6, and that won't work. Because A is 1, it should be an easy factor. We go right to the multiplication problem. So X up front in both, and then a -1 and a -8. Factors of -12 that sum to +4. Don't worry about the negative. Let's just get the factors of 12. So 1 and 12, 2 and 6, 3 and 4. Okay, one of the two of these factors has to be negative, but the sum has to be positive. So the smaller factor should be the -1. Okay, so that product is -12. That sum is 11. Not what we need. Let's make the smaller number the negative. When we sum these, we get 4. That is what we need. And you could just double check to make sure that this doesn't work, and it doesn't. Okay, so we don't have to do factor by grouping. I'm going to double up and put two problems right here, side by side. In both 4 and 5, notice there's 4 terms. I can't call that a quadratic trinomial because I don't have 3 terms. So what I did up here is out. So I'm going to just kind of say this is a natural break in my problems here. I have to use factor by grouping on both of these. So attempt both of them and then come back and see how you did. Nice that there's a plus there. I don't have to change either of these signs. I never am going to change signs up here because I have the parentheses after the subtraction sign. Okay, let's take out common factors. An x will come out of both of these terms, leaving x plus 1. Check by multiplying back in to see that you get back to what you had, and choose the common factor here. We're in good shape. We have the same quantity, the same parenthesis. Let's factor that out. When I factor out x plus 1, I'm left with x and plus 2. And you could FOIL to check that you are going to end back up with this expression. This was a little weird because you might have noticed, hey, I could have collected those first. And yeah, you probably could have. And, you know, made it a quadratic trinomial by putting these two terms together and then factoring it like we did in the previous 3 problems. Same thing with number 5 here. If I were to put these two terms together, I'm going to get x squared plus 4x minus 12. Well, connect back up here. That's exactly the same problem here. So let's say I just went through the factoring by grouping. Should I get the same answer that I had here? Because number 4 is actually like your first example up here. If I were to combine these like terms and make this a quadratic trinomial, I would get back up here to this problem where I could use this method and get this answer. Okay, but I did end up with the same answer even when I factored by grouping. So even though I know this answer is connected to this problem, we're going to verify that factor by grouping does also work. And remember, you're about to put a parenthesis behind this minus sign. We never change anything up here. It's always after the subtraction sign. So 2x, but not minus 12, but plus 12. I'm going to take out an x, leaving x plus 6. Keep the minus. I'll take a 2 out, leaving x plus 6. The common parenthesis is x plus 6. And when I factor it out, I'm left with x and minus 2. Same answer as number 3. It's just that my parentheses ended up being in a different order. Right, I'm going to run out of room, and so I'm going to work on another sheet of paper here. Let me move that out of the way. What was that last example? 5, so I'll move on to 6. All right, inspecting this. This is a quadratic trinomial. A is greater than 1, so we are going to have to factor by grouping, but we're still using that factor sum chart. So my comma. List factors of 12. I'm just going to ignore the negative for right now. Okay, touching base, I do need a negative 12 product, so one of the two of the factors has to be negative because the sum of those two numbers when one is made negative needs to be positive. I'm going to let the smaller of the numbers in my sets be the negatives. So if I made that negative, that product is still negative 12, but that sum is 11, too big. Make the 2 negative to get negative 12, but when you sum, you get positive 4, still too big. 3 must be the negative, add, you get 1, so this is the set we're going to use. So coming over here, we cannot go straight to a multiplication problem because remember, a is greater than 1, so we're going to have to do the factor by grouping. So that meant keep 2x squared and keep the minus 6, but where plus x is, we're going to rewrite it as minus 3x and plus 4x. Those will collect and give us that 1x in that original problem. Now we proceed with the factor by grouping. I have 3 more problems. I'll write all 3 problems down first, and if you want to pause the video and work them out and come back and check, of course you can always check by foiling, you know, to make sure you're on the right track, but you can also just come back here and check too. 7. Eight, and trying to leave a little space here for 9. Factors of 6, 1 and 6, 2 and 3, and that's it. The product has to be negative. The sum's negative, so the bigger number in the set of factors has to be the negative. So when I multiply, I get -6, but when I add, I do get -5. So it looks like this one won't work, and no, it won't. So we now have the two factors that we need to use as coefficients to break up that middle term. So keep 2x squared. Personally, I would write the -6x first, and then the +1x, or just x, second, and then return to the original problem and grab that last term. So we're keeping the first and the last term, breaking this middle term, okay, into the sum of these two terms. And by choosing to put the positive x here instead of the -6x here, I don't have to worry about making a mistake in changing a sign. Uh, 2x comes out here. And when I factor out a 2x, I have an x. And when I factor out a 2x here, I have a -3. Notice that this is already the same quantity as what I have here. So I've got the plus. So I don't have a common factor, but I can put that placeholder of 1 in front, that understood multiplication, because I'm going to need it now. Okay, factor out the x -3, and you are left with 2x in the other parenthesis. And then you need that +1. If you need more practice, I'd be happy to meet with you on office hours and work out some more problems. Factoring it just takes time. All right, I need one of the numbers to be negative to get a -6, but I want the sum to be positive, so the smaller of the two numbers should be in each set should be the negative. So that does give -6, and that sum does give 5. If this was made negative and I added, that'd be 1, and that's not what I'm looking for. So keep the 3x squared, break 5x into -1x and +6x, because that collects back to 5x, and then keep the last term. Common factor of x. Divide x out, that leaves 3x, because that product gets you back there, and then minus x divides out of itself 1 time. And then 6 and 2 share a factor of 2, so that'll come out. And do I have the same quantity in the parentheses? Yes, I do. So we'll take that out next and complete this problem by making a multiplication problem. Six times -12 is -72. Ooh, that's large. And b is -1. All right, I just go through the factors methodically so I don't miss a set. So 1 in 72, 2 in 36. Use your calculator. 3 divides into 72 24 times. I think 4 goes in there 18 times. 5 does not go into 72. 6 does 12 times. 7, no. 8, yes. 9 times, and then 9, but then I'd start repeating. Okay, so I need to make one of the two factors negative, and I need to make the larger factor negative so that when I add them, I get a negative answer over here. So that multiplies and gives me negative 72, but when I sum, I get negative 71. Too big. That does give me negative 72, but when I add, I get negative 34. That sum is negative 21, getting closer. That sum is negative 14. That sum is negative 6. That sum is negative 1. So again, I'm going to choose to put the minus 9x first and the positive 8x second to avoid that negative there, and then don't forget the minus 12. Uh, 3x will come out from this first set. 2x minus 3, I believe. I gotta check it by multiplying, yeah. And then 4 divides out of 8 and 12. So that'll leave 2 here with an x and 3 here. Yep, and all is well and right because I have the same binomial. Okay, and I'm left with 3x plus 4. All right, so I hope that helped.